Hello everyone, this is Shalini from St. Andrew's Institute of Technology and Management. We strive to deliver the best education possible in the industry. The subject that I shall be looking forward to is Principles of Operating System, which is a CSE 4th semester subject. The topic that should be covered are Introduction to OS, Generations of OS, Types of OS, and OS Services. Now, what is an operating system? See, our operating system is nothing but an interface between the computer software and the hardware. So, it is a first program that is being loaded into the computer by the boot program, and it will manage all the other application programs in the computer. So, what we can say is that an operating system is a software which performs all the basic tasks like file management, memory management, process management, handling input and output, and controlling peripheral devices such as disk drives, printers, etc. Some of the common examples are the Windows and the Linux. As we can see in this figure, the user is interacting with the application, and the application interacts with the operating system, and the operating system is the one that is residing on the hardware, and it has a direct communication with the hardware. There are basically four generations of the operating system. The very first generation spans from the year 1945 to 1955. So this was the time when vacuum tubes and plug boards were used in actually this was the time when actually computers came into existence. So machine language was used for all sort of programming. So basically there was no need actually of the operating system, because it was usually started with doing simple maths calculations. The second generation spanned from 1955 to 1965, and this generation changed with the discovery of transistors. So transistors made it possible for computers to be actually sold to people who were ready to pay a price for it. And in this, batch processing was introduced. So what is a batch processing system? Wherein you pool a group of jobs, right? Pooling a group of jobs means like you actually put it on a tray that is full of job, and then you insert it into the computer and you get the output after some whatever be the time that it takes to execute them. The third generation computer from 1965 to 1980s. So this generation came with the discovery of integrated circuits, or what we call as ICs these days. And what was the technique that was used was multiprogramming. Multiprogramming is the technique wherein one computer can actually execute more than one program. So like with the first programs, it goes out to use the input output operations, or it halts for any reason, then the second program takes over, and you actually do multi-programming between the two. This is how the third generation computer looked like. Okay, fourth generation started from 1980 to present day. This came with the development of large scale integrated circuits. Large scale integrated, see, the size of the chip was decreasing day by day, and the circuitry that could be put on the board was increasing. The more and more complexity was starting to increase, and the size were getting reduced. So actually this made computers ubiquitous. So we can see that they started changing forms also, from desktop to laptops to tablets. Even a smartwatch, if I having it, is also kind of a computer to me. Why? Because it has a CPU that does some execution, it does your work, it takes your information, it takes input, it processes it, and it is giving an output. Then we come to types of operating system: simple batch system, multi-programming batch system, multiprocessor system, desktop system, distributed OS, clustered system, real-time OS, and handheld system. Simple batch systems. In this type of system, there's no direct interaction between user and computer. Like we discussed now, with the second generation of computer, we used to collect the jobs, and we used to offer it at once. We used to put it on a tape or drive or something, and then we used to insert it into the computer. So there was no actually direct interaction between the user and the computer, right? So it places several jobs onto one input device, and they were batched together as on the properties of language and whatever similar requirement that they had. So this is how, like, you can understand from this diagram, there is an entirely different area for operating system. wherein the user program area is entirely different. See, the two are entirely different. There are very well defined boundaries between them. So this is one of the advantage, that there's no interaction between the user and computer, and you don't need any mechanism to prioritize the process. So it's very simple. Okay. The next is multiprogramming batch system. See, in multiprogramming batch system, the operating system picks up and begins to execute one of the jobs from the memory. So once this job needs an input output, then what it does, it switches to the next job. So the two are being executed, we can say, at the same time. We can say this. So this is how multiprogramming is being employed in it. And if jobs in the memory are always less than the number of jobs on the disk, right? If several jobs are ready to run at the same time, then the system chooses which one to run through the process of CPU scheduling. So it will decide as to which process it will take first, and which it will take second, and how it is going to schedule it. In non-multi-program system, there are moments when CPU sits idle and it does not do any work. Wherein in multi-programming, we can say this. Okay, this is very similar to time sharing system. In time sharing also, this was divided into that this time you will execute, this time you will execute. So it can be said that if we talk about if I talk it in terms of mathematical functions, there are some functions which are event driven, right, triggered, and there are one which are already periodic events. Okay, so time sharing systems are also multi-programming systems, but these are very periodic systems, right? And the primary focus is to minimize the response time and maximize the CPU usage. Okay, advantage is enhanced performance. It is very well clear that it enhances the performance of the CPU, and there are several tasks by different processors. They actually increase the system's throughput without speeding up the execution of a single task. If possible, system divide tasks into many subtasks, and then these subtasks can be executed in parallel in different processors, thereby speeding up the execution of single task. Desktop system, we have seen this, and this is very common. Like, these are multi-user multitasking system. They're like with lots and lots of features. This is very common. Like, and goals of this is to, as the time has produced, it has become very kind of we are accustomed to it. Like, example, as is a generation, we have just seen the system. Like, common example, Windows and Apple Macintosh. Okay, now distributed OS. See, the motivation behind developing a distributed operating system is the availability of powerful and inexpensive microprocessor and advances in communication technology, right? So these advancements in technologies have made it possible to design and develop distributed system, which comprises of many computers that are interconnected by communication network. So the main benefit is it is very low priced, and the performance ratio is very well. So there are basically two types. We can categorize it into client server system and peer-to-peer system. Client server, in client server system, there will be a central server which will be servicing the clients, right? Where in peer-to-peer system is like both having equal, I would say, equal kind of a they are at par with each other. So that is, he said, that is why I named it, as the name suggests, peer to peer. So these are actually nodes that are equal participants in data sharing, and they are equally divided between all the nodes. The nodes interact with each other as required. What are the advantages? Very fast processing, very low cost, very less load on the host machine, right? And excellent utilization of resources, I would say. Clustered system. See, clustered system, there are a group of systems that gather together multiple CPUs to accomplish a computational work. They are different from parallel system. However, they are composed of two or more individual systems that are coupled together and behave as one single system, right? The definition of the term clustered is not very clear. The general accepted definition is that clustered computers share storage and are closely linked by LAN networking. It is usually performed to provide high availability. So a layer of cluster software runs on the cluster nodes. So each node can monitor one or more of the others. If the monitored machine fails, the monitoring machine can take ownership of its storage, right? So the system doesn't fail. It's clear? So the failed machine can remain down, but the user and clients of the application will only see a brief interruption of service because the other person has taken clear, like the other system has taken over it. Okay. Real-time operating system. It is very it is defined as the operating system known to give maximum time for each of the critical operation that it performs, like OS calls and interrupt handling. The real-time operating system, which guarantees the maximum time for critical operations and compete them on time, are referred to as hard real-time operating system. So these hard time operating system, if I can give an example, are the operating system that are installed into nuclear reactors, fission reactions, fusion reactions, or into the satellite communication or rocket propellant kind of stuffs. Soft computing system are wherein we can give a little relaxation of time, that are not so critical task. Like suppose if I have a meeting scheduled in there, and I have to do something. So it may not be it is not having very high kind of a value, like very high priority does not have. So this comes into soft real time operating system. Okay, handheld system. Us as a generation, we had seen a lot of handheld systems. Like I was talking about, there are a lot of personal digital assistant, tablets, mobile phones, smart watches, smart glasses. These days, lockets are also coming up. And some parents, they actually keep a check. If the child is small and the parents are working, they actually keep a check onto it. And so this is very, very ubiquitous. These devices have between 512 KB to 8 MB of memory. So the operating system must manage memory very, very efficiently, right? So this includes returning all allocated memory back to the memory manager once it is no longer being used. Currently, many handheld devices do not use virtual memory techniques, thus forcing program developers to work within the confines of limited physical memory. So you see, the complexity of the OS, like it would increase, and the processors for most handheld devices often run at a fraction of the speed of a processor in a PC. Faster processors require more power. To include a faster processor in a handheld device would require a larger battery that would have to be replaced more frequently. The last issue confronting program designer for handheld devices is the small display screen typically available. This is very, very common, like self understood now. One approach for displaying the content in web pages is web clipping, where only a small subset of a web page is delivered and displayed on the handheld device. Suppose if I have a smart watch being into my hand, I have a smart watch. So the display size has to be very, very small. We can understand very, very common examples that we are doing it. We are I would say we are actually being applying into our daily life, day to day lives. Okay. Next we come to the last topic, that is operating system services. See, the operating system provides services to both the users also and to the programs also. It provides programs an environment to execute, and it provides user the services to execute the program in a convenient manner. See, understand the difference between the two? Providing the programs an environment and the user to be able to the service to actually execute those programs in a very, very efficient manner or convenient way to him. So that is you being user friendly and program friendly both. So following are few common services provided by an OS: program execution, input output operation, file system manipulation, communication, error detection, resource allocation, and protection. First we come to program execution. See, the operating system handle many kind of activities, from user program to system programs like printers, spoolers, name server, file server, etc. So each of these activities is encapsulated as a process, and the process includes a complete execution context. So some of the common work that it does is it loads the program into memory, it will execute the program, it will handle its execution completely, it will provide a mechanism for process synchronization, for process communication, and for deadlock handling. So complete program execution is being taken care of by the operating system. Next we come to the input output operation. An input output subsystem comprises of input output devices and their corresponding driver software. Driver hides the peculiarities of a specific hardware devices from the users. So an operating system manages the communication between the user and the device driver. The input output operation means read or write operations with any file or any specific input output device. and operating system provide the access to the required input output device when which is actually needed, right? So who does the scheduling? Like suppose any process, if it needs any, so and it need to access, say for an example, I have a word file which has to be printed, so it has to be connected with the printer na. So this scheduling, when it would be printed, and taking the hard copy of the printout, and then again um, taking you back to your programs, is actually all this is done by the operating system. Clear? So next is the file system manipulation. File system is normally organized into directories for easy navigation and usage, and these directories contains many subdirectories, right? So the file management is all done by the operating system. The program needs to read a file or write a file. The operating system gives the permission to the program for any operation that it has to do on the file, and these permissions vary from read only to read or write, or restricting you or protecting you. So anything has to be done by the operating system. It actually provides an interface to the user to create and delete files. It provides an interface to the user to create and delete directories, and it provides an interface to create the backup of the file system. So each and every file management job is being done by the operating system. See how important it is. Communication. See, in case of distributed system, so it's basically a collection of processors that do not share memory, peripheral devices, or a clock, and the operating system manages communication between all the other processes, right? And these are actually geographically distributed at different places. So multiple processes, they communicate with one another through communication lines in the network. So the network is the medium of communication between these different if different nodes into a distributed system. So the operating system, it handles the routing and connection strategies, the problem of contention and security. So all the major activities with respect to communication. Two processes often require data to be transferred between them. Both the processes can be on one computer or on different computers, but are connected through a computer network. So communication may be implemented by two methods, either by shared memory or by message passing. Error handling. Anytime an error appears, pops up, so who handles it? The operating system handles this, and the operating system has to constantly check for more possible errors. Operating system takes appropriate action to ensure correct and consistent computing. So this is error handling task is done by the operating system. The resource management, scheduling of different resources, the CPU scheduling, any kind of disk scheduling, everything, each and every kind of resource management, input output allocation, what resource to be allocated to what program, everything, every resource management is to be done by the operating system. Protection. Considering a computer system having multiple users and concurrent execution of multiple processes, so these must be protected from each other's activities, right? So the protection refers to a mechanism in which you control the access of the program, processes, or users to the resources defined by a computer system. You're actually restricting. So some of the major activities are: the operating system ensures that all access to system resources is controlled. It ensures that external input output devices are protected from invalid access attempts, and it provides authentication feature to each user by means of passwords. So security or protection, this is very important aspect, and this is done by operating system. So I can say every operation that is being done on the computer is done by operating system. So it is the most important thing. So we come to an end. Some important questions are: what is an operating system? What are its functions? What are the operations? What are the operations of operating system? Right. So the examiner can ask you in different ways. What is the need of operating system? What are the different types of operating system? You have to explain it in detail. What are the different generations of operating system? So we've covered this topic. For any doubt, please contact